Hi, this is Fazana again. In part 3 of this video, we will cover some interesting higher level questions on trigonometry relating to right angle triangles only. They involve surds and algebra, and they test you to see whether you can apply basic principles to harder looking questions. Let's cover the basics before moving on to some examples. Okay, so I assume you're familiar with Sohcahtoa. So the sine of an angle is opposite divided by hypotenuse. So it's always that divided by that. The cos of an angle is the adjacent divided by the hypotenuse. And the tan of an angle is the opposite divided by the adjacent. And I'm sure you're okay with labeling the triangles. The side opposite your right angle is the hypotenuse, which is the longest side. The side opposite your angle is the opposite, and the side that's got your right angle and the angle is the adjacent. Okay, all right, let's do some questions. Okay, it says the diagram shows two right angle triangles, ABD and CBD, and they give the lengths. Okay, and they say cos x equals tan y. And you think, oh God, X and Y's, and what do I do with this? So the minute you see the right angle triangles, you think it must be trigonometry. Okay, so let's label our triangles here. The side opposite your right angle is the hypotenuse. The side opposite the angle is the opposite, and that's your adjacent. Okay? All right, so it's saying cos x. So cos would be the A and the H. So cos x would be A over 18. Okay? And they're saying that is equal to tan y. So let's label this triangle. So that's your H, that's your O, and that's your A. Yeah? So tan y is O, which is 8 divided by A. All right, so we've got that. Okay, now if you remember from my other videos, the Fazmaths, where I say I just take two very simple fractions which are equivalent, and you know you can cross multiply. So 3 times 4 is the same as 6 times 2. So here we can go A times A is A squared, and 18 times 8 is 144. Okay, and then all you've got to do is square root to find A equals 12. And, the length of BD, which is what we're trying to find, is the A. Okay, so the length of BD is 12 centimeters. All right, okay, it's just an odd looking question, but as long as you apply the basic principles, the workings just fall into place. Okay, let's try another one. The diagram is made up of two right angles, so you know it's got to do with trigonometry. The length of SR is 5. Work out the length of QR. Okay, so again, as I said, if you get two triangles and they ask you to find that length, chances are you've got to start with this triangle first, and they're saying tan x is 0.8. So let's label our triangle. So that's your H, that's your O, and that's your A. So tan would be O over A. So tan x is 0.8 equals O over 5. So if you use my Faz format of 3 equals 6 divided by 2, then in order to find the 6, you just go 3 times 2. So we just do 5 times 0.8. So O equals 5 times 0.8, which is 4. Okay, so you can see we're just getting closer and closer to that. Okay, so let's do this one. It's saying cos y equals 0.9. So 0.9 equals, and let's label this triangle. So this time that is the H, and that is your O, and that's your A. Okay, so cos would be the A and the H. So you've got A over H, which is the 4. Okay, A is actually the length of QR, so as long as we get this, so again we use that format. So A equals 0.9 times 4, which is 3.6 centimeters. Okay, can you see how it flows? Once you just apply the basic principles, you start playing around with the diagram and everything falls into place. Okay, let's try another question. Okay, write down the exact value of tan 60. So I've done videos on doing the exact values, but if you don't know how to do it, what you need to draw is an equilateral triangle, because you know each side there will be 60, and then split it and make all these sides 2, 2, 2. Now if you split that triangle in half, then that will be 1. Okay, so here you've got a right angle triangle, and then that's your hypotenuse, and that is your opposite, and that's your adjacent. So tan would be O over A. Now we need to find out what O is, which is one of the shorter sides. So O would be the square root of 2 squared, which is the hypotenuse, minus the other shorter side. So it's actually surd 3. Yeah? Okay, so the tan of 60, so that is surd 3. And the tan of 60 is O over A, which is surd 3 over 1, which is just surd 3. Okay, so that's surd 3. Cool. Find the exact area of this triangle. Okay, so it's just a regular right angle triangle. So again, prepare. We know the area of a triangle is half times base times height. So I'll just go put the 4 surd 3, and now we know we just have to find that. Okay, so we're just going to put times, and once we get the answer, we'll stick it in. Okay, so let's label our triangle. That's your H, that's your O, and that's your A. Okay, now we know the value of tan 60. So let's just say tan 60 equals O over A. So it's O over 4 surd 3. Okay, and we know tan 60 is surd 3. Okay, so again, with my Faz format of 6 divided by 3 equals 2, we know we can cross multiply. So O equals 4 surd 3 times surd 3. You know a surd times itself gives you the number, so surd 3 times surd 3 is 3, and then 3 times 4 is 12. So we've got our O, which is there, and then we can go stick it in there. Now half times 4 is 2, so we've got 2 times 12 is 24, so our answer is 24 surd 3 centimeter squared. And then of course you stick it in there. Okay, all right, and that was an easy 5-mark question, wasn't it? Yeah. Okay, now this question here, you can pause, take a break, go have some orange juice, get some energy, and let's tackle one of these, because it looks really ugly, but I'll show you when it comes to with the X, and again, we're just applying basic formulas. Okay, ECEF is a trapezium, Okay, so those are our parallel sides, and then those are the other two sides. EC is parallel to FDB. Okay, yes. CD is parallel to EF. So really, if you think about that, that should also be X. Angle CBD is 50. So we know that that one is 40. Can you see how I prepare as I go along? So I'm always like one step ahead. Angle DEF is 20. Cool. So that one's also 20. You've got the alternate angle just in case we need it. Yeah. So you can tell that triangle would be the same as that triangle. Angle EFD is 90. Okay. Express in terms of X the length of DF. Okay, so we have to find that length there. Okay. Again, you can tell it's to do with right angle triangles, so it's trigonometry. So let's label. That's our H. That's our O. And that's our A. Okay, how do we find the length of DF? Okay, so let's use our O and our A. So we've got tan 20 equals DF over A, but we know it's X. Yeah, so we're expressing it in terms of X. So DF using R3 equals 6 divided by 2. DF equals X tan 20. Okay. All right, so that's our part 1. Okay, the area of triangle DEF. Okay, so part 2, triangle DEF. Okay, so we know we're going half base times height, and we know that O is actually that there. So we're going half times X times X tan 20. So we've got half X squared tan 20. Okay, and that would be area DEF. All right. Okay, part B, the percentage of the trapezium that's not shaded. So we want to find the area of that divided by the area of the whole trapezium times 100. Okay, so again, let's prepare. We're going to go DEF, so the area of DEF divided by the area of BCEF, and then we're going to convert that into a percentage. Okay, and can you see we've already got the area of DEF, so we've got half X squared tan 20. Okay, now you can tell we need to find the area of the whole trapezium. Okay, so when we come to our parallel lines, you can tell the area of the trapezium is A plus B divided by 2 times the height. Yeah? Okay, so we're going to go CE plus BF. Okay, so you can tell we need to find BD first. So we're going to go BD equals, okay, let's label this triangle. So that's your H. We'll use that 40. So we'll have O. Okay, so let's see what we're going to find. We want to find the O, and we've got the H. But in this case, that's not the H. That's your A, isn't it? Yeah? Okay. So we've got the O and the A. So again, we're going to go tan 40 equals BD over X. So using that format, we can see BD equals X tan 40. Okay, are you with me? All right, now we should have enough to find the area of the trapezium. So the area of the trapezium is half, which is that divided by 2, and then we'll multiply by the height first, so at least we know we're going to get something in brackets, so half x, and then we add the parallel lines. So you've got CE, which is the same as the O, which is the same as DF. So you've got X tan 20, and then we're going BF. So BD is X tan 40 plus, and then DF with X tan 20. Okay, all right. Can you see that they all have x's? So you're going to go half x squared, and then you've got tan 20 and tan 20, so you've got 2 tan 20s plus tan 40. Okay, so that's the area of BCEF. And then you stick it in here, half x squared, and then 2 tan 20 plus tan 40. Okay, the half x squareds cancel out, and you're left with tan 20 divided by 2 tan 20 plus tan 40 times 100 to convert it into a percentage. And when you put that in your calculator, you'll get 23.2%. Okay. It was quite a intense question, but can you see you're just sort of taking it as it comes? Your basic principles are labeling the triangles, knowing the area of the trapezium, and so if you just go with it, always prepare beforehand. If you know that you need something, just underline it so that when you do need it, like that, it's easily visible. Yeah, so then you just keep writing. When you get to that point, you think, oh look, they cancel out, but it really helps to prepare first. Okay, I hope these videos on trigonometry will help you tackle any exam questions on this topic. In exams, you need to identify that it's a trigonometry question, which you will, as long as you play with the diagram. The more you use your pencil to communicate with the diagram, the more the diagram speaks to you. It works, trust me. I mean, you can tell I said, oh, that's X, oh no, it's A. Yeah, it sort of speaks to you, and it tells you if you're doing anything wrong. And then, of course, remember how to label the triangle and apply basic principles. Keep working hard, and remember, you're in control. Until next time, take care. Bye.